Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Organizing code effectively begins before a single line is written. In professional development and IT work, the first step is designing the logical flow of a program so its purpose, structure, and decision points are clear. Planning tools such as Pseudocode and Flowcharts make it easier to map out a solution in a way that can be reviewed and refined before implementation. Logic structures provide the framework for how a program makes decisions and repeats actions. The Tech Plus certification includes questions on these planning tools and concepts, making them an essential skill area for candidates. Pseudocode is a text-based method for outlining a program's steps using a simplified, structured language that reads like plain English. It describes the logic of an algorithm without worrying about the exact syntax of a programming language. This makes it valuable during the planning stage when the focus is on solving the problem rather than writing the final code. Development and IT teams often use pseudocode to ensure everyone understands the intended logic before work begins, bridging the gap between technical and non-technical stakeholders. A well-written pseudocode outline uses logical statements to describe conditions, actions, and the sequence in which they occur. Clarity is emphasized through consistent indentation and clear language that matches the intended program flow. Common features include decision-making steps, repetition for loops, and descriptions of outputs. Because it removes the distraction of syntax errors, pseudocode is especially effective for brainstorming, documenting processes, and teaching programming fundamentals. Flowcharts, on the other hand, present a visual method for organizing a program's logic. They depict the start of a process, the actions to be taken, the decision points, and the possible outcomes, all in a clear, diagram-based format. Flowcharts help identify gaps or inefficiencies in the logic before a single line of code is written. They are widely used not only in software design, but also in IT operations, where process mapping can improve workflows and troubleshooting steps. Standard flowchart elements use simple, consistent shapes to represent specific components of logic. Ovals often indicate starting or ending points, rectangles represent actions or processes, and diamonds are used for decision points that branch into different paths based on conditions. Arrows connect these shapes to show the flow of execution. By clearly showing logic paths and potential loops, flowcharts make it easier for teams to understand and improve a program structure. Logic is the engine that drives program flow, dictating how software reacts to different inputs and circumstances. Logical structures ensure that actions happen in the correct sequence and that programs can handle varied scenarios reliably. Branching logic allows a program to follow different paths depending on the conditions at hand. When logic is designed accurately, it ensures predictable and correct outcomes, which is essential for reliable software behavior in both IT and business systems. Conditional statements are the building blocks of decision-making in software. These statements evaluate whether a given condition is true or false and direct the program to act accordingly. They can be as simple as checking whether a user is logged in or as complex as evaluating multiple factors to determine a course of action. Conditional logic is foundational to almost all software, making it a key topic for both programming and automation tasks. Comparisons and logical operators refine decision-making by checking relationships between values and combining or negating multiple conditions. Comparisons might determine if one value is greater than another, while logical operators allow for compound conditions, such as requiring both criteria to be true or accepting either one. These tools give programs the ability to make nuanced decisions, enabling complex branching and control structures that adapt to different data and scenarios. Loops are a fundamental way to automate the repetition of actions within a program. Rather than writing the same instruction multiple times, a loop can repeat it until a certain condition changes. This is essential when processing lists, waiting for events, or performing repetitive calculations. Properly designed loops reduce redundancy, improve clarity, and make it easier to adjust a program's behavior without rewriting large sections of code. Different loop types suit different needs in programming. Some loops execute repeatedly while a condition remains true, while others are designed to run a set number of times. Selecting the correct loop type for a given situation improves both performance and readability. Proper loop structure is critical to preventing unintended repetition or infinite loops, which can cause programs to hang or crash. Efficient loop use is a sign of well-organized code and a disciplined programming approach. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Controlling how loops execute is vital to maintaining stable and predictable program behavior. Without proper controls, a loop can run indefinitely, consuming system resources and potentially causing a crash. Logical conditions are used to determine when a loop should stop, and these conditions are checked at every cycle. Additional controls, such as break statements, can interrupt the loop when specific criteria are met. By clearly defining loop boundaries, developers ensure that programs remain efficient and easy to troubleshoot. Breaking program logic into smaller modular parts makes it easier to understand, test, and maintain. Modular logic allows each component of a program to operate independently, so changes or updates can be made without affecting unrelated sections. This approach supports collaboration among multiple developers and simplifies debugging because problems can be isolated to specific modules. In the long run, modular structures lead to cleaner, more reliable software that can adapt to changing requirements. Planning logic before writing the actual code is one of the most effective ways to prevent errors and save time. Tools like Pseudocode and Flowcharts clarify problems, outline potential solutions, and make it easier to see how the pieces fit together. Early planning is especially valuable in collaborative environments where different team members may have varying levels of technical expertise. By finalizing the logic first, teams can avoid costly rework during the coding stage. When troubleshooting software issues, IT professionals often review the underlying logic to identify where the process breaks down. Recognizing how conditions and loops interact allows a technician to pinpoint the exact step that caused an unexpected result. This skill is also useful when reviewing logs, analyzing scripts, or verifying process automation. Structured thinking and an understanding of logic flow enable faster problem resolution and more accurate fixes. Flowcharts and Pseudocode each serve a distinct role in planning and communication. Flowcharts appeal to visual thinkers and are effective when presenting a process to stakeholders who may not have a technical background. Pseudocode provides a more detailed, text-based representation of the logic, which can transition directly into programming code. Choosing between them depends on the audience, the complexity of the problem, and the preferred workflow of the team. On the Tech Plus exam, you may encounter scenarios where you must choose the correct logic structure for a given problem. Some questions may ask you to interpret a flowchart to determine the program's output or to analyze pseudocode for accuracy. Other items might test your knowledge of branching logic, loops, and condition evaluation. Understanding both the purpose and the structure of these tools will help you answer confidently across multiple question formats. Glossary terms to focus on for this topic include logic, pseudocode, flowchart, condition, branching, loop, operator, and sequence. Instead of simply memorizing definitions, practice identifying how these terms relate to each other in real scenarios. For example, think about how a loop fits within a branching decision, or how a condition affects the sequence of steps. This relational understanding reinforces retention and strengthens problem-solving skills. In IT and development work, logical thinking is at the heart of every process, from writing scripts to managing network automation. Clear organization of logic not only improves efficiency, but also enhances communication between support teams, developers, and management. Whether you are troubleshooting a complex system, automating a repetitive task, or reviewing a colleague's code, The ability to follow and refine logical flow is an essential professional skill. In the next episode, we will begin Domain 5 of the Tech Plus certification, Data and Database Fundamentals. We will start with an overview of how data is valued, stored, and used to support business and IT decision-making. You will learn about data capture, correlation, reporting, and monetization. Join us for Episode 45, Data and Database Fundamentals, Domain Overview, as we move into another critical area of the exam objectives. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.